All right, hi class. Really quickly, I wanted to take a look at question number 4 from assignment 14. I ended up not counting it against you if you got it wrong, because I realized that there may have been a little bit of disconnect between my class and 171. So I'm going to go over it, and I'm going to go over two different methods that you can use to solve any type of question that uses the imaginaries and wants you to go back to a polynomial function. Okay, so just like the other problems, if I give you the zeros, you're going to set x equal to. So I know I have x. Hang on. I know I have x equals 2 for one of them, and then the other one I have x equals 2 minus I. But here's the thing. Just like on question number 1, I gave you, I believe it was 6 minus I, you also have to have the complex conjugate. You have to have x equals 2 plus I. Because remember, that I is in place of a square root, so we have to have a plus and a minus. So one way that you can go about doing this is obviously get your factors. We're going to have x minus 2 for this guy. Again, I move both of these over to the other side, so they change signs. So I get x minus 2 plus I for one. And for this one, I get x minus 2 minus I. Okay. So one of the methods is to multiply out, obviously, the complex conjugate first. So I'm going to use the box method. So I'm going to do x minus 2 plus I in one box, and then the other one obviously is going to be my x minus 2 minus I. And I'm going to be very careful when I go to multiply these. So I get x squared minus 2x, that becomes a plus ix. This becomes a negative 2x, positive 4, negative 2I. This becomes a negative x, xi, whatever. This becomes a positive 2I. And then this last one, positive times a negative is going to be a negative. And this I times I is I squared. Now, just like everything else, I'm going to add diagonally. So these two guys go together. These three, and then these two. Okay, so when I put it all together, I get x squared. This becomes a negative 2x, it becomes a negative 4x. That negative ix and positive ix end up canceling each other out, so all I have is that plus 4 in the middle. And then, of course, that positive 2i, negative 2i, they cancel each other out, and I am left with that negative I squared. Well, remember, I squared is technically a negative 1. So, again, I have x squared minus 4x plus 4. This becomes a negative 1, and obviously a negative 1 makes that a positive. That positive 1 adds to that 4, so I end up with x squared minus 4x. This becomes positive. That's 4 plus 1, so that's a plus 5. Okay, so this is the factor for my complex conjugate, and I'm going to take and bring down that x minus 2. So I get x minus 2. Okay, and now again, I have to multiply again. You can use another box method. At this point, sometimes I cheat a little bit and I create a box right underneath my trinomial, draw my lines, making sure I realize that the signs are with the number that's to the right of them. And then I have my x, my minus 2. All right, so I get x cubed, negative 4x squared, and a 5x. Let's see, I get a negative 2x squared. I get a positive 8x, and then negative 2 and positive 5, negative 10. So finally, once I do all of that, I can put them all together, knowing that my squares go together and my x's go together. So I get x cubed That becomes a negative 6x squared, a positive 13x minus 10 for my final answer. Now, I consider this to be the long method. I prefer a method that works every single time, okay? And that is, I go back up here. I'm given my two zeros, okay? So again, I'm gonna do it in a different color, sorry. I'm gonna do x equals 2, and then I'm gonna set the conjugate, x equals 2 minus I. Now, the really cool thing with this method is I have to make sure that the I is kind of by himself. So I'm gonna move that to, actually, hang on, wait, yeah, I'm thinking about it. Yeah, I want the I to be by himself, so I'm going to move the 2 over to the other side. So minus 2, minus 2. So we get x minus 2. All right, and it's a negative I. No big deal there. How do I get rid of an I? Well, I need to square it, so it becomes a negative 1. So I'm going to take and I'm going to square both sides. So remember, what I do to one side, I do to the entire other side. Okay, so I end up with x squared, that's a minus 4x, and then a positive 4. And then that negative I squared. Well, remember, that's like saying negative I times negative I. Negative is a positive with an I squared. Of course, that I squared, we already know, becomes a negative 1. So I move this down. And then I just add the 1 to the other side. So I end up with x squared minus 4x plus 4. This is my factor. I got it. Okay, the only thing I have to do from here is bring down that x minus 2. And then I can use the box method again, exactly like I did right here, right? I skipped the headache of having to multiply two trinomials together. I went ahead and I just said, okay, how do I get rid of an I? Well, I have to square it. And this works every time. I think I gave you one where it was x equals 2I, right? Well, again, I'm just going to go ahead and square both sides. Whichever side has the I on it, I'm going to square it. I don't like fractions. I don't like anything complicated, okay? If there's a number being multiplied to it, leave it there. Don't move it, just leave it there. So again, I take and I square both sides. So I get x squared equals what ended up being 4I squared. So I end up getting x squared is equal to 4 times a negative 1. And then I get x squared equals a negative 4. Well, I move it to the other side and I get x squared plus 4. Okay, I'm trying to think of a little more. No, this works every single time. Really, you're only going to see ones where I give you like x equals 5 minus I and things like that, or 5 plus I. We'll do plus I. Right, same thing applies. I move the 5 to the other side because it's only being added together. So I get x minus 5 equals I, right? I'm going to square both sides. So I get x squared, that becomes a negative 10x plus 25 equals I squared. Well, we know I squared is actually a negative 1. And I know I'm going to have to move him to the other side, right? So he gets to be x squared minus 10x plus 26, okay? It's a quicker method if we just square both sides to get rid of the I immediately. It's all the same math, but you are skipping so many steps just by squaring everything on both sides. Remember, if it's just x equals 3I, we leave the 3, right? And we square both sides. But if it was x equals 3 minus I have to move the 3. Okay, this is the best example I can give you for a new method, a faster method to multiply out the conjugates. I hope this helps you. If you have any other questions or you would like me to work any other problems, I will happily do so and post it to Blackboard. I hope you have a great evening.